by giving you gifts. So we already have to say thank you.
Thank you.
This is Mr. Richard Campbell, who has started his own company from his own research and discovering something absolutely awesome, something that is life-saving, something that is life-changing. How we can grow food with rocks. Don't you see rocks in front of you? And you see all the wonderful things that are being grown with these rocks. So his company is, are you with me?
Yes.
His company is To Soil Less. To soil less. So that means that we can grow without soil. We'll eventually be to soil less. There you go, you have it. There you go. So, Mr. Campbell has come all the way from Washington, D.C. to be with us this morning. And so we want to come that early and come with gifts. We are so thankful from the beginning.
Glad to be here.
And so we'd like you now to meet our 4th and 5th graders from the Patterson School District. And they come from several schools in the area. And so they are ready for you.
Well, thank you all for coming out today. How are you all today?
Good.
You're good? You're good? Okay, great. My name is Richard Campbell. And like shared earlier, we can grow plants and rocks now. We figured this out by accident about 25 years ago. And so we've been growing plants and rocks for about 25 years. And we've gotten to a point where we can come and teach it to society and kids all over the place, like you guys today. So, as you've seen and heard, we have a gift bag for everybody. So what we're going to spend our time doing is looking at the rocks in front of you, and I'm going to talk about the plants in front of me with these gallons. These are only just a couple weeks old, and so right now we're going to go through our gift bag. I want you to look in your gift bag. Okay, slowly. Now this is the book. Okay, first just pull out the book. First, just put everything back in but the book. This is the book that teaches everything we know about growing plants in rocks. Okay? So all that we know so far, well, up until last year. This year we learned a lot. And so but this is what you're going to take home with you and share with mom and dad. And you want them to really read chapters 1 and 2. Okay? Because when you read chapters 1 and 2 with your parents, you understand how this came about, that we now can grow plants and rocks. And then what you guys can do at home during the winter, before the springtime, to grow your own food at home with your families. Okay? So, let's take it all back. How is it that, okay, first off, who here has ever heard of growing plants and rocks? Raise your hand if you heard of it before today. All right. Do you know where you heard it before? School. Okay. That's right. And where do you usually grow plants in? Where do you normally grow plants in? Soil. Right. Has anybody grown plants in soil before?
Yes.
Everybody? You have many times? Okay. So people, you like to garden? Some gardeners in here. Raise your hand if you're a gardener. All right, we like our gardeners. And so what we're going to talk about today is growing plants in rocks. No soil, no fertilizer. So in front of you on your tables, and let me pull one up while I walk around. Here, we've got sand at the bottom and rocks, okay? And about 10 days ago, we planted from seed these broccoli sprouts. Now, broccoli sprouts, they are a highly nutritious plant. And the #1 cancer fighter in the world, broccoli sprouts, because of the amount of sulfur in them. And so this is what you can eat in, say, 10 days. If you have cancer, this is what we would recommend you do. Now the good thing about growing plants in rocks is after you harvest this, see this plant is ready to eat now. And it's very good and tasty. If anyone wants to taste it, we encourage you to. But once we eat it all, you can put more seeds in it again and it'll grow back. And so you can always grow in rock over and over again. That's the benefit of rock over soil, is that rock will grow for you for the rest of your life without adding any nutrients or fertilizer. So let us explain why. So, did anybody take classes on science yet? Anybody got some science folks? Did you all take any classes about the Earth, the planet Earth, in science class, about the rocks of the Earth? You're doing a project about the planet Earth now? And the rocks. Anybody know the types of rock? Did they teach you the types of rock? Anybody know any types of rock? Granite is a type of rock. Conglomerate is not necessarily a type of rock, but it's a good, strong word. Calcite is a type of rock. Any of the broader categories of rock? You know it's three broad categories of rock. Granite and calcite are within one of them, but there are three broad categories. Do you know?
What about a rock? Is the limestone a rock?
Limestone is a rock, but it's not one of the three broader categories. It's part of one of the categories. Sedimentary rock. That's the one, most important one, right? Igneous, that's right.
Oh, I think I know this one.
Marble is not one of the, it's a type of the last one, but not quite. Metamorphic.
Aren't they brilliant?
So that's three types, there's three broad categories of rock. Now, what we figured out by accident was sedimentary rock. Let's talk about sedimentary rock. That's the rock.
Sediment?
It's made with sediment, exactly. But what is the sediment specifically? Anyone? Anyone know what the sediment is in sedimentary rock? Anyone?
Sediment is pieces of is broken down pieces of rock.
Sediment is broken down pieces of rock. Almost. Well, in some areas of science, that is the case when you look at layering of the earth. But in the case of sedimentary rock, anyone know what the sediment is? What's that? Minerals. They're close and generally correct.
There is the building blocks of the sedimentary rocks.
The sediment in sedimentary rock would be the building blocks of sedimentary rock. That is true. Okay, how about this? Anyone know where sedimentary rock is formed? Where does it come from? Does it come from
Beaches.
beaches? Very close. It's actually technically correct. Go ahead.
From a delta.
A delta, very good. Beaches in delta are what? Areas of where? Water. Sedimentary rock is rock that is formed in water 50 to 150 million years ago, generally speaking. Igneous and metamorphic are land-based rock formed on land. Now, so again, if sedimentary rock is formed in the water, that means oceans, rivers, and lakes, what is the sediment? If it's very close, and in some areas of science that would be an accurate statement, and it is. Sedimentary rock does have portions of clay in it. But what is the sediment in sedimentary rock that's formed in oceans, rivers, and lakes? Okay, what lives in oceans, rivers, and lakes? Fish. Fish. Now let's think about that. So the sediment in sedimentary rock is basically fish. Dead fish parts, dead organic life. Technically, we would say it's organic material. And so that's where science stopped in its knowledge and understanding and really pursuit of the word sedimentary rock. because yes, it's organic material, but it's really, that means dead fish. So this rock that you see acting this weird way, growing plants in just a short period of time, these are all just 7 days old. It's because this is dead fish part rock that's fossilized into a rock over millions of years. You got a question?
Yeah.
So basically, add water to this rock and out comes nutrients. All right? And how long will a rock last? If it's already about 50 to 150 million years old, is it going to outlive us?
Yeah.
Right.
I already did outlive some of us.
It already did outlive us, right? And so, how long do you think, if you add water, so I'm saying you add water to the rock, it's going to put out nutrient materials from a 50 million year old dead fish part. How long do you think that rock will be able to do that? And our lifetime, do you think it'll do it past our lifetime?
Yes.
So therefore, the rock will provide nutrients to water for at least our lifetime. All right? So that means we can use the rock to grow plants for a lifetime. So all of the rock in here that's growing these plants, once we harvest and eat it, we can reseed and do it again, and do it again, and do it again. Now, let's look at the nutrients. You all, who knows that it takes nutrients and fertilizers in soil, right? Everybody knows about fertilizers? Raise your hand if you know about fertilizers. And what does fertilizers do?
It helps the plants grow.
It helps the plants grow. And everybody always asks me, Richard, what's the fertilizers? How is the plants growing? So this year we did a test. We took a lot of our plants and we took samples and we sent them to the top 5 labs in the United States. Say, hey labs, tell us what the numbers are on these tests. What's the nutrients coming out of the rock that allows us to, make plants? So, in your book, I want you to open your book and find a page. There's a page in your book, a sheet of paper.
Oh.
All right. This is where we get all our science. Adults in the back, even our colleagues and, okay, everybody. Our camera person too. Our camera person's an adult. All right. All right. So first thing we're going to do is we have to figure out what the rock is feeding the plant. Okay? And this is where science kind of missed it. We used to put rock in soil and thinks that the rock can help the soil. So there's a lot of research out there doing that. But what science missed was that you needed to put the rock next to water. Now this next little experiment should be experiments that you do here in science class. And the experiment goes like this. You have a cup of water by itself. Okay. Then you have another cup of water, but you have rocks in it. So go get your local rocks from outside. Put it in a cup of water. And get another cup of water with some other rocks in it. And another cup of water with some other rocks. And you let those waters in that blank cup of regular water, no rocks, sit for about a day, 2 days, 3 days, any number of days you want. And here we did it for 10 days for 2 different types of rock. Now you can do it the same way for any type of rock in adults for any number of days. And what you're going to find is when you test the waters, test the water A against water B, against water C, against water D. And the difference tells you what the rock is putting into the water so that the plant can grow. Okay? So let's look at our fancy sheet here at our water test. That's what we call them. Our rock water test. And they're going to tell us the nutrient value of the rock. See, previously we didn't think that rock could do anything like this. But now the water test demonstrates that rocks have nutrient value. So let's look on the page where we have UGA at the top. It says gravel water versus tap water. UGA, a Clemson test. That means I went to the University of Georgia lab and gave them water samples. Then I went to the Clemson University lab and gave them water samples. Now for Georgia, I gave them water samples of this rock type, the one that we all see and that's in the mainly what we use in the book. For Clemson, we gave them rock samples from the Outer Banks in North Carolina. Anybody know where the Outer Banks is? All right, yeah, some people may go vacationing there. It's along the coast of North Carolina. But that rock represents ocean rock. So we're going to test ocean rock and river rock. All right? So now let everybody look at our test. All right, we see there at the top, we see the base tap water. And then we see gravel 10 days. That means we had the rock in the water for 10 days. Who can tell me how much more nitrogen was added to the water on the gravel test? Who can tell me how much nitrogen here is going to be NO3-N? That's considered nitrogen. What's the percentage of nitrogen that was added? Anyone? 35%. That means in 10 days, that river rock added 35% more nitrogen to the water. All right, what about potassium? Remember NPK? Everybody likes NPK. What about potassium? How much more potassium? 28%. So now we're seeing that these elements, what about calcium? 65%, right? Now, below in the writing, we kind of give you an overview of what these micronutrients do for plants. So we can show you specifically why the plant is now growing. We see that the rock is adding these nutrients, and below we describe what they do. Now let's look at the test below that. That's the ocean rock. Who can tell me the nitrogen level of the ocean rock after 10 days? So, in the river rock, what was it?
35.
Right, and the ocean rock is, so which rock is going to give you more nitrogen? The ocean rock. That means the ocean rock at least is going to win in the case of nitrogen. Now what about potassium? Remember now, NPK, we all like potassium. How much is that ocean rock doing? Go ahead. Yeah, you? No, you're all right there. You know you got it. Go ahead.
274%.
270. Now what was potassium in the river rock? Go ahead. 28%.
Very good.
Now do we understand why the rocks are feeding these plants? You see that kind of nutrients going in that water? What about, now let's look at calcium. Calcium, go ahead, you got it? And then what was it in the river rock? Correct. Now what that means is this, charts like these now give us all a road map. If I'm looking for calcium, what rock am I going to use? If I'm looking for calcium, what's the better rock? River rock. If I'm looking for potassium, what's the better rock? Go ahead. Oh, the Outer Banks rock. Correct. So now, we all, not just us for plants or me, we can use data like this for our plants, to understand what the plants are taking in, and also for our health. All of these nutrients, has anyone ever seen these nutrients before in science class? Yeah, has a whole entire chart with all of them. That's right. What's that called? What's the chart called? No, you got that. First of all, high five. What's the chart called? Periodic table. So when we did this, we didn't do the regular ag way with NPK. We did the pretty much top left-hand corner of the periodic table. Why? Because these are the elements of the earth, of our plants, of our bodies, of our medicine, and of our food. So we're able to show clearly with scientific precision of what the rock is feeding the water. Okay? So now we know the power. What else do we know about these rocks? How long will the rocks last?
Forever.
Longer than our lifetime. That's right. So we know what the rock is putting in the water, which time assures. And we know that we can do these water tests. So first of all, who wants to do a water test with their rocks at home and stuff like that? All right. Well, hopefully your teachers will figure out a time where we can do that in your classrooms, and y'all can bring rocks and test them in waters and figure out a test. All right? All right, now let's look and see what the plant is going to put in our body if we eat it. Okay? We see these plants. Are they nutritious? Are they healthy? Well, the rock water test suggests, do you think that the water test, what do you think the water test suggests? That the plants are probably good or not good? The water test, the results we just looked at. Probably going to be good. So let's turn it on the other side and see. All right. All right, you ready for this? I know, right? It's a lot of little writing. So what we'll do is we'll just look at the top. You see the colors? Okay, and then you see all the way to the left, you see all of the plants that we tested. And also these are the seeds that you'll be able to grow at home that's going to be able to grow and you can eat in 10 days. So we've got those two plants. Then we have peas, cilantro, wheatgrass. Wheatgrass is right here. Now, this is expensive to get. It's called wheatgrass shots. People use them for energy and that kind of thing. It's like $8 to take these and make a juice shot. So very expensive. But as you see here, not expensive for us, is it? Now, how much these rocks cost? They was free. They was outside. They was outside, got these rocks. And so that's the other plant we tested. And then beans, string beans. Who likes string beans? All right. And so this is what 7 days. So 7 days. Now we see the string beans starting, right? See the little string beans? It's going to take about 6 weeks before he gets into the full bean that you can eat. And this is the other seed that you can choose today to take home with you. So you can choose the string beans that gets tall, or you can choose the pea shoots that you can eat. This was done basically in the dark. When you do it in the dark with gravel, it will still grow, but the leaves will be skinny. It'll still be very nutritious. So for those who choose the pea shoot, they're going to grow bigger. Now let me show you how the pea shoots look. Turn to page 269, all the way in the back.
269. 269.
269, all the way in the back. Now you see how the pea shoots look on the packaging in 10 to 20 days, right? And you see how they look in gravel in 14 days. So all of that is basically your salad. It's highly nutritious. So that's how those pea shoots look. When I test my gravel plants, they're going to lack, some of them might lack a little boron. At least the microgreens do. At least those sunflowers and wheatgrass. Lacks a little boron. And the boron will be a natural preservative. So that's something you might add if you wanted to have that. Anybody tell me another, what plant has a little lower calcium count? Anyone? Okay, go ahead. Yep, pea shoot microgreens and peas. They're part of the same family of plant. All right, so that's what's a little lower when compared to the soil. Now everything that's green with no numbers in it is where the gravel and the soil are equal in nutritional value. And then everything where it's dark green is where the gravel has more nutritional value than the soil. So who can tell me some of the nutrients coming out of these plants that are dark green? Like generally speaking, what do the trends say? What are some of the dark green nutrients? You yell them out. Anybody got a dark green? Go ahead. Phosphorus. Phosphorus is very important for the body. Anything else? Anyone else? Sulfur. Let's see there. Yep, sulfur. Anyone else? Go ahead. Molybdenum. Exactly. Copper for some plants. Now let me ask you this. If you wanted molybdenum in your diet because of what it could do and you have some type of sickness and molybdenum was what was needed, what plant would you eat? Beans. That's right. If you wanted more iron, people can take iron tablets, right? Spend a lot getting iron tablets into your body, low iron blood. So what plant might you eat if you wanted more iron? You said beans. Beans, probably, but if you really wanted that iron jolt, what plant would you eat? Cilantro, right? So now we get to see where more nutrition can come from. What if you wanted more sulfur? You know, sulfur is what makes sulfurine, that ingredient that helps fight cancer. So if you wanted some sulfur, what might you eat? Pea shoot microgreens, exactly. That's one of the plants you get to choose today. And so, now if it's blue, that's where gravel shows up the numbers, but soil, they don't have numbers available. So already we're seeing that gravel-grown foods are putting in a lot of nutrition. And that's the point of this chart. It's not in the book because we did these tests after the book was produced. But this is what shows you a roadmap of the nutritional value of the rocks, the water, the plants. And so this is what you share with your parents when you get home. And they should review this closely and chapters 1 and 2 closely. So let's all now put, go ahead and put now that we know the nutrition is good, right? You see that nutrition? Let's go ahead and fold it back up and put it back in your book. So look, so this plant was looking a little gloomy. This plant was looking a little gloomy. We've got about an hour left. Now the reason he's looking gloomy is because I had him with me at a conference the other day. And that conference, I had him out and I took him out of water. You can only have these plants out of water 1 or 2 days before they start to look a little droopy. But we've got about an hour left in this presentation. So what we're going to do is we're going to put Mr. Droopy Droop in the sunlight. Sunlight makes everybody smile too, right? So let's see if this sunlight is going to make everybody smile. You might want to take a picture of Droopy Droop beforehand. Go ahead. Let's take a picture of Mr. Droops. We'll come back and see if he's perked up a little bit. So then we tested all of the rocks at the store. Guess what happened? Who can guess? What happened when we tested all of the rocks at the store, not just the sedimentary river rocks? The other rock. They died. Okay, that's one option. The other rocks died. It worked. All right. So we got die or work. Die or work. All right. Who's on the die side? 1, 2, 3, 4, 5, 6. Who thinks they all worked? Yeah, they all worked. All of the rock in the store worked. To my surprise, I felt all kind of like some type of way about it. I've been doing this for 20 years, 25 years, concentrating on one rock, not looking at all of the rock. And so this particular rock is one such rock. Mine. So we're going to talk about this rock for a little bit. But this is a hyacinth. It's flowery. Now we're going to bring it around and just take a whiff. Smell it. Smell it. Smell it. Smell it. Can you smell it? Usually these bloom in the springtime. And so this is grow in this weird kind of dwarf way, and it'll come up like a ball. It's not kind of how it grows in soil. In soil, it grows a little more pronounced. Okay, so this is a situation where we are using this other type of rock. It is growing, but pound for pound, it probably grows a little better in soil, even though this is still fragrant and organic, nonetheless. So rock is not going to be better than soil in everything possible, but it does allow you to grow a lot of things permanently. And you can still make your house smell awesome in the winter or all year round. The thing about these environments is that they last a lifetime. So once this goes full and does a full bloom, I can take it out and start over. Do it again. Take it out and start over and do it again. Take it out and start over and do it again. For the rest of our lives, right? Because it's rock. Now, one thing about this is that, what do you see at the bottom there? Anybody know what that is at the bottom? Sand. Which is made out of rocks, yes. Sand is also sedimentary. Okay? Now, why sand? Anybody know why sand?
Because sand has a bunch that gives it more minerals, so it be able to grow.
Something like that. Sand it is more improving. Sand is a natural water filter and cleaner. Sand cleans water naturally. So in filtration systems, they run water through sand to help clean. So one, we use a sand as our irrigation system. If I use soil, soil will drink the water. Sand passes the water through. Okay? So now what we need is a way to water this, but not keep it waterlogged. A lot of times if we have a vase, or all of our conventional pots and containers don't really work here. Because with a vase, it will all be in one container and you wouldn't have water flow and airflow. If it's a terracotta pot, the pot drinks the water. If you have the pots you have in the stores, they have big holes in the bottom and all the sand will fall out. So what we have to do is we have to retrofit a container to make it work. Okay? So we have sand at the bottom, but we have tiny holes at the bottom. The tiny holes allow for water to go in. They're irrigation holes. We then have tiny holes on the side for air. Because what do we know about this rock once we get it wet? It's going to start putting out nitrogen and sulfur and a whole bunch of other stuff, right? We saw those charts. So once this gets wet, it's going to start boom, boom, boom. So we need the air to help with circulation and reduce decay. If you don't have the air, you'll have greater chances for decay. And so, what you have in your cup, in your bag, you have, I want you to pull out the cup Tacking. Cup and tack. Remember our friend, right? What we're gonna have to do is we're gonna make our air holes and we're gonna make our drainage holes with the tack. The tack is the tool of the indoor gravel garden. Now, although we are training you on these training cups, we want you to use old recycled plastic material. Your water bottles, your liter Cokes, your gallons, your Fiji bottles, whatever that, the trash. Go out in the trash, get the bottles. We're gonna cut them. I'm gonna show you. Just what I mean. And so, you ready? Check this out, right? Although I'm gonna train you right now on those cups, what I want you to end up thinking about for a family at home with mom and dad is take recycled cups, and when you do them, squeeze them down, it makes it easier to cut. Okay? So this is what we want you to actually use at home. Or bigger versions, or like I took my baby girl's gallon of milk, or lemonade. Okay? So you get a lot more food. A lot more food. All right. Now let's go back to our training cup. What I'm going to do first, I want you to watch me first, and then we're all, the adults are going to watch all of us do it. Okay, and I'm going to come watch it. So I'm going to make, I'm making holes all around the edges. I'm going to make about 6 holes all the way around the cup, and that's going to be, and that's going to be my water drainage. So now go ahead and make 6 holes on the edge. All around. All the way around. If it's 5 or 7, it's okay.
Good job.
Just do 3. Just do 1, 2, and 3, and then do the one that has up and fill them 1, 2. You need help?
You got how many?
I have 6 right now.
You have 6? Okay, great.
All right.
Got it?
These cups have a little line on them already. On right, just tiny bit right at the line. You're gonna do 4 holes all the way around the cup. It's cross air, so you have a cross air hole. 4 holes all the way around. Or halfway, yeah. Halfway in the cup at the side. There's a little line there. 4. Some would say 90 degrees, right? 90-degree angle.
The bottom? 6.
I don't know how good it's going to be.
8.
It's nutritious.
Watch me.
For days, absolutely.
Good job. Much better. Just try to be careful so we don't get our finger. Go ahead, please. Want to do one more?
As you all know, you all recognize those pins. Use them every day in class. Or you see them, you know what they are. And you know why we use them and how we use them. Now, it is pretty certain that at least 30 to 40% of you are going to lose your pens. But that's okay. The point of today is to know what the pen can do, what it's used for, and how to make these gravel growing containers. Now this container is ready to be a gravel growing environment. If you didn't put these holes in there, there would be problems. It took us about 5 years to figure that out. This is generation 5. And but the point of the exercise is to know that that stick pin is really all you need. You get your plastic from the trash, scissors, holes at the bottom, holes on the side. And when you go for the kill, because you know that mom, grandma love broccoli sprouts, you go to the gallon surprise, happy birthday. You put a bunch of tiny holes in, not just the 6, proportional. Okay? Remember, this is designed for that sand to bring in the water. Okay? Irrigate this place. All right? Now, any questions? Is there a question? Can you use any rock?
Great question.
Great question. Anybody have an answer based on what we talked about earlier? You can use any rock, but what do we know about rock? Is some rock better than other rock?
Yes.
Big difference, right? Did you see that potassium level? 16% with 274%, something ridiculously different. Now understand that some rock is better than other rock, right? But remember that nutrition report. The top rock, which was less valuable than the bottom rock, well, that top rock is what the book was written on. So it's good enough. But of course, if you find better rock out there, it's good. But the question is, can you use any rock? Yes, but some rock is not going to work as good as others. All right, so if you have a rock that's not doing your plant good, like I don't know if I like this performance here. Maybe another rock could perform better for this plant. It's a specialized type of plant. And so, in our travels as the science evolves, we figure out that. So we know that ocean rock is better than river rock. We also found that rock from Africa is better than rock from the United States. Because we believe that rock to be older. Think about it now, right? Rocks are between 50 million and 150 million years old, right? So the 150 million year old rock is going to have more sedimentary material baked into that rock than the 50 million year old rock, right? So the older the rock, generally, the more nutrients it's likely to have. And that rock over there, the more older, I don't know if you studied this in science classes, how the Earth was a supermass and it broke into continents. Right? Well, the continents that floated away, they're probably a little younger in geological adaptation than the ones that kind of stayed in the Central European group of continents. And then there are the layers of the earth with rocks. So in my capacity so far, we haven't gone down that deep. But as a science, as a species, humanity will begin to do that. To figure out what's the best rock on the planet. What rock are we going to send up with our astronauts? Where's that rock? Is it in Singapore? Is it here in the US? Gambia? Amazon? And so that's the type of thing we'll be trying to figure out. Now, this next thing I'm going to do is show you. But
You get an excellent idea, question, brings it out in your science class.
Does the color of the cup affect the grow? No. However, the placement of the holes do. If your holes are low, you're going to be in the wrong zone. These holes are low in this particular cup. So we're going to take this stuff. So teachers, look at what too low of holes look like. Holes this low, let me tell you all of the things that happen just by putting your holes too low. Okay? Now there are a lot more than 4, which is perfectly fine. But when they're too low, they're going to affect the irrigation, which we'll soon see, and they're going to affect the airflow. The airflow needs to be where the action is. If it's too low, the airflow will be where the sand is. See right here, we have the airflow where the center is. That's where the action is. If you have the airflow down here, the plants will suffocate up there. Okay? So that's why you need to be very careful to make your air hole halfway through. And we're going to just do that real quick. Now, as it relates to other types of containers, clear or plastic or different colors, it won't matter. The rock is going to do what it does in any type of environment. But the key is moisture control. Inspections, all right, we're good to go. Perfect. All right, we're good. We're good. One of you would drop and make a mess. And you all don't all go to this school, you all are in the same class. So this next thing I'm going to show you, you're going to keep for memory. You can take a video of it. Or if you go to YouTube and Google Gravel Grow Cup commercial, you can see it. Now I'm going to show you how we're assembling the Gravel Grow Cup, and then you're going to go do it at home tonight. Okay? You're going to do it, set it in the window, and watch the magic happen, as they say. Now, I want you to look in your bag and verify, take out, just verify a bag of sand and a bag of rocks. All right, everybody see it? Everybody saw the sand and your rock. All right, you go to the store like we recommend you do. We only want you to get it free on the ground for survival purposes. If you cannot go to the store and buy it, and you're about to die, get it from the ground for sure. But otherwise, go spend the $4, buy a bag of rocks. Now, how many cups can I make with one bag of $5 rocks? How many cups? How many little Gravel Grow Cups? This is a Gravel Grow Cup. I'm about to show you how to make them. How many do you think I can make with one bag of rocks? Now, a bag of rocks is $5. So $5 of cheapy rocks. 2, 3, 10, 5, 6, a million bazillions, 19, 28. All right. 100. All right. If you make the bags of rock, the Gravel Grow Cup this size, in one $5 bag, you're going to make 65 of these. All that will last, how long? Throughout the rest of your lifetime. So that means 65 of these roughly makes up a 6-foot table. So we're saying per person, human, one bag will likely give you your nutritional needs for the rest of your life. Because everybody gets their own 6-foot table with food. Right? And so that is so today, I'm going to show you the one skill to do that. We got our cups, right? We got our holes. So who knows how to make the holes in the Gravel Grow Cup? Who knows how to make these holes in these cups? Who can take a cup and make it ready to grow in rocks? Who knows how to put the holes in the bottom and the side? Raise your hand if you know how to put the holes in the bottom and the side. So how many times could you do this? Like if I gave you 100 cups, could you put holes in all 100? About 200. So basically for the rest of your life, you know how to do this now. But now I have your Gravel Grow badge. All right, so a bag of rocks, $5 bag of rocks, weighs 40 pounds. You know how when you go to Home Depot, you get the big bag of soil? It's a big bag of rocks. Except the soil costs $8 to $12. Rocks cost $4 to $8. Soil you have to buy every year. Rocks you buy one time and use it for the rest of your life. So you calculate that soil you have to buy a bag 8 to 12 every year. Most people have to buy 2 or 3 bags every year. But rocks that one time, eat on it for the rest of your life. So math folks, y'all can, teachers, y'all can have all types of fun math with volume of 9-ounce cups that are 65 per bag. Well, what if we change the volume to gallons? How many gallons would you get per bag? You would get less. Or how many liters would you get per bag? That's the kind of things you can do in class to understand what one bag gets you if you really wanted a lot of food. What if you wanted to do one like this? Size. You could. So the point is to know that this is possible for you. Now, when you get home, you're going to make your gravel grow cups. The first thing you're going to do is you're going to take your sand baggie and pour it in your cup. But you're not going to do it right now. Just watch. Put the sand back in the bag. Put your sand back in the bag. Take the hand off the sand. So what you're going to do is you're going to pour all of it out.
Are you watching?
All right? So you're going to pour all of it out. But if you leave it like this, slanted, it'll mess it up. You won't have good water moisture. It won't be even. So you got to do a little shake and bake. All right? Shake and flat. Now it's ready. Okay, so first you're going to put in your sand, shake and flat. Then you're going to get your box. Not now. Remember, you know why we don't want to do it right now? Who remembers? Somebody's going to drop it. 4 people would drop it before they got home. We don't want anybody to drop it. Because your mom was going to be mad. All right. When you get home after that sand, now you're going to do the next thing. Now, one thing about packaging on seeds. So, something about seeds. The packaging on seeds says 1/2 inch or 1/8 inch below. Shallow. This is 1/4 to 1/8 inch below in the soil. That's that deep. If you plant, here we go. So these are the pea shoots. So up here, this is the dry zone. It's always going to be dry at the top. Down here is the moist or active zone. This is where the action is happening. So, and then this is the sand irrigation or wet zone. So where do the seeds need to go? The dry zone, the active zone, or the wet zone? The active zone, right. So in the active zone in rock, it's below. See, in soil, you put the seed up here in the top, like on the packaging. But if you seed it like on the packaging in gravel, nothing will happen. That's the area where it's dry. You have the seed below in the area where it's wet. Okay? And the sand only makes it wet to here. And then the nature dries rock out from the top and keeps it moist. So keep that in mind with seeding. So what that means is, when you go to pour your sand, you're going to pour 1/2 of it, not now, 1/2 of it in your cup when you get home. Excuse me. Yes. Sand is already in. So you're going to, now you get the rocks, and you're going to pour 1/2 of it into the cup. Watch this. Okay? Basically up to where your holes were. Okay? And that's where you then put your seeds. Okay? Now, everybody gets a choice of seeds, and we've got the sunflowers with all the things. That's actually rock and earth. Just that You want to plant the seeds that are good for indoors, like all your microgreens and your sprouts and your peas and your beans. Your cucumbers and your squash and tomatoes you have to do in your outdoor gravel gardens because they're a little more complex and they need the bees. You know how they talk about bees and plants? You know about the bees and the plants and the bees and the pollination? Well, some plants really do need these. And without the bees, there is not going to happen. And so some of those more complex plants that could use the bees and the worms and real sunlight, like sunflowers, the actual sunflower plant. That's an outdoor thing. That's not going to do good indoors. Unless you have incredible super lights, then sky's the limit. But in general, we say all that to say that what you want to always remember is that all of the different varieties of plants, you want to experiment first. And so how we help you with that is we're going to turn to page 65 in the book. Uh, 64. Okay, everybody see that chart there? One thing we had to do as we developed the science for the people is that we have to kind of make it easy for you. You're not going to know what to expect with all the different plant types. Right there you see about 40 or so different plants that we have experience with, but there are about 100,000 different species of plants on the planet. Now that's where we're going to put our seeds. So now what we're going to do is we're going to start passing out the seeds. Okay. We got two types of seeds. Both of them will allow you to eat in 7 to 10 days. 7 to 10 days later, you'll be eating. Okay, so we've got seeds that taste like sunflowers and seeds that taste like peas. Peas and sunflowers. Peas and sunflowers. Okay, so I'm going to give everybody their own seed pack. Okay? And what you're going to do, when you get home, remember I did this halfway? Everybody looking? Everybody looking halfway? We're going to pour all the seeds. Okay, now I'm going to give you your seeds now, but you get to choose what seeds you want. So this is halfway, right? And then afterwards, after you do the seeds halfway, you're going to pour the rocks on the... Alright? And that's it. Now, that's it when you assemble it.
Put your cup
The cup. And then you're going to... So now, the seeds are in there. You all see the seeds? So you see how halfway? Okay? Halfway. Alright? You all can go do this at home now, right? Can you all you all know how to go home and take the materials in your bag to make one of these? Everybody can do that? Now watch this. This is the really good part. You know we talk about water and scarcity of water and all the movies and say the water's going to disappear and all that. Well, like Avengers. Who knows about Avengers? Thanos, the bad guy. Yeah. This whole thing was scarcity of resources. So we have to kill off a lot of people because there's not enough food. A lot of people think that. With rocks, now everybody can have access to food, so you don't have to do that anymore. But let me show you something. Any type of water. Any type of water is fine. All right, guys, you ready for this? Okay. What I'm going to do now is show you how we water this. Who's got a tiny drip tray? This is a big drip tray. Who's got a tiny one in there? Okay, let me see. Okay. All right. We've got 3 styles of drip tray in your bag. 3 different styles. Some of you have this one. Okay. This one is designed for this cup, and that's what we're going to show you first. Most of you have this one, but the other 2 has something special about them to talk about. So right now, we're going to add water to this container. I'm going to show you how to water because it's very important. The way you water is important. So all I'm going to do, and this is what you're going to do when you get home, is you're just going to add water, and it goes to the top and stop. And it's just going to drain on its own. See, the water is coming out. You see it? Coming out into the drip tray. Now, because these are rocks, the water cannot go inside the rock. It can only go on the surface area of the rock, around the rock. So basically, pretty much 99% of that water is going to drain to this drip tray. Okay? And it's almost all gone now into the drip tray. And then the sand is going to bring the water up. As whenever this rocks get dry, the sand is going to bring the water up and feed the plants seed that's right there and roots, and now start to grow. So now the water is in here. This is now considered on. All right. Looks like our guys are ready for serving. They're awake now. They're not grumpy lumpies anymore, are they? They're sleepy drippies. So who wants to taste it? Now.
You like it? What's the taste?
Halfway.
I can't.
You don't know. Who's eating?
Ask her what she thinks.
What you think?
And I want you, when you go home, I want you to Google this, sunflower microgreens with your parents. Right over.
It tastes weird.
Right? I want to see your face. Come on.
Yes, it is.
It tastes weird.
Yes, it is.
You didn't like it? You like it? Yeah?
You can eat the whole thing.
Cool.